In this tutorial video, we will be learning on Controlled Arbitrary Rotation Gate. We will be doing this in Google Colab. Like we did in previous video, we will start with installation of Blueqat. We can do it by using this code !pip install Blueqat. Type the code that was shown earlier in Google Colab. Then click on play button and Blueqat will be installed. Controlled Arbitrary Rotation Gate. In this video, we will see different gates used, and to make circuit of the gates. CRX, CRY, CRZ gates. These gates can be implemented by the following. Theta remains same for RX, RY, and RZ gates. CRX gate. Value of theta will remain same for all the gates. If we run this code, we will get 00 as the output. Now let's try this in Google Colab. Type the code shown earlier. Now click on play button. As you can see, the output is 00. CRY gate. Here we use CRY gate, and as you can see, theta value remains same. If we run this code, then we get this SN output. Let's confirm this by trying in Google Colab. Type the code that was shown earlier. Now click on play button. As you can see, the output is same. CRZ gate. As told earlier, the value of theta remains same, and if we run this code, then we will get 00 as output. Let's confirm this by trying it in Google Colab. Type the code that was shown earlier. Now click on play button. The output is 00. CU1, CU2, CU3 gates. These gates can be implemented by the following. Theta, lambda, pi, remains same for CU1, CU2 and CU3 gate. CU1 gate. Here we can use CU1 or C phase keyword. If we run this code, then we will get 00 as output. Let us try both code in Google Colab. Type the code with CU1 keyword. Click on play button. Output is 00. Now I change the keyword CU1 into C phase. Now click on play button. As you can see, it gives same output. CU2 gate. Here we use CU2 gate, and if we run this code, we will get 00 as output. Type the code shown earlier. And click on play button. As you can see, the output is 00. CU3 gate. If we run this code, then we will get the same output, that is 00. Type the code shown earlier. And click on play button. As you can see, we get the same output, that is 00. CRX, CRY, CRZ gates. Here is the matrix of these gates. Clearly CRX does not have a minus sign, nothing gets inverted. CRX corresponds to the C0 gate. Operating only with C0 gates does not provide any quantum speedup. C0 gates can be implemented classically. Not so, however, with CRY and CRZ. For example, CRZ can be used to invert the probability amplitude of the marked states in Grover's algorithm. CU1, CU2, CU3 gates. Here is the matrix of U gate. With this gate, they define the following gates. These gates are the basis, with CX of the IBM Q online back ends, that is the real chips. The CU1 and CU3 are the controlled operations associated with the matrices above. That's all for today. Thank you.